This is going to be another example of broken access control. We're going to be making use of this lab. User role can be modified in user profile. The objective of this lab is to access the admin panel located at /admin and to delete the user with the username Carlos. There is a security control in place preventing regular users from accessing the admin panel. And it's simply that a user needs to have the correct role ID in order to be associated as being an administrator. And administrators on this web app have the role ID of 2. We didn't have to figure that out. It's given to us here in the lab guidelines. So it's completely impossible for a user without the role ID of 2 to access the admin panel. The problem with this particular web app and why it falls under the category of broken access control is that it's possible to change the role ID of our logged in user. So if we can change our role ID to 2, suddenly the web app is going to see us as an administrator and hence let us access the admin panel. Okay, without further ado, let's fire up the lab. Now we are given some basic credentials for a regular user. So let's log in as that regular user. And we'll notice that if we try to access the admin panel, that we can't access the admin panel. We have the wrong role ID in this case. If we explore the GET request to /admin, we see that there is a cookie, but it only contains the session token. If we could guess the session ID for an active session of an admin user, we could use this to access the admin panel, but that's going to be very difficult to do, and that's not going to be how we solve this lab. If there was a role ID key value pair included as part of this cookie, we could simply tamper with that. That would be another example of broken access control, but that's not the correct attack vector here. Returning to the lab, if we head to the My Account section, we see that there is an input field here. We're always especially interested in input fields because it's generally one of the ways that we're going to get a payload through to the underlying web app. Let's check out the regular usage of this input field. The idea is we can change the user email. So let's change it to new email at email.com. Let's choose update email. Let's inspect that request in Burp. So we can see that it is a post request. We can see our session cookie included with that post request. And we have a body with the post request. It appears to be a JSON object. It has one key value pair, and the key value pair is email with the value of the new email that we've sent. Now it's interesting that this is a JSON object because it doesn't need to be. It could simply be a key value pair with email equals new email at email.com. But instead, it's specifically being provided as part of an object. On the back end somewhere, the server is obviously receiving this particular object and using it to update user information in the database. So the obvious question here is, can we use this object to update information on the user that we aren't really supposed to be updating? For example, the role ID. So let's send this to the repeater. We're going to tamper with that JSON object. We're going to specify a role ID, and we're going to give it the value 2. Role ID in double quotes, :2. Now, where did we get this information from? It was given to us in the lab guidelines. So we are assuming the name of the key here is role ID, lowercase, and we know that the value is 2. Without this information, the attack wouldn't work yet because we'd have to figure out the name of the key here, role ID. That would need to be exposed somewhere else in the web app. Otherwise, we simply wouldn't know what we're trying to modify. But in this case, we already know this information. We're assuming we figured it out by some other means because it's given to us directly in the lab guidelines. Returning to our tampered request, let's send this. We get a response here. And the thing I really like about this, it's a JSON response with the full user object. So it's telling us, yes, that was successful. Here is a copy of all of the information on the user after the changes. So you can see we also have an API key. We know the username and email already, but we have confirmation that the role ID has now been changed to 2. So that updated role ID is now going to be associated with our session. So we should be able to navigate directly to /admin. And since our role ID has been updated to 2, we're now being associated as an admin. The objective of the lab is to delete the user Carlos. So let's follow that link. Carlos is deleted. We get the flag, congratulations, you solved the lab. This is a little bit of a less obvious vulnerability than some of the previous broken access control labs. In this case, the developer had protected the /admin root with a session cookie. On surface value, it appeared as if the /admin root was secure. The problem in this case was that there is a way to change the properties of each individual user. So now our regular user session cookie becomes associated with being an administrator because we were able to manipulate the value of that role ID. Either way, the end result really is a full takeover here because we now have access to administrator account as a regular user. All right, hope it was helpful. Thanks very much for watching.